In this video, we are going to see the topic quadratic equation, and we are going to see how we can write a C program to find out this quadratic equation. Fine. Okay, so before we write a program for this equation, we should know the logic first. Okay, we should know the logic, how we can find out this quadratic equation. Okay, as you can see the slide, there are three cases has to be checked out for this quadratic equation. So what are all the three cases? If determinant value is greater than 0, we have to find out the root 1 and root 2. Okay, and if the determinant value is equal to 0, where we have to find out only the roots, that is root 1 and root 2. Okay, so in simple words we can say that is root 1 equal to root 2. We calculate only one root if the discriminant value is equal to 0. And what about the third case? If the determinant value is less than 0, where we have to find out the real part and imaginary part. Okay, so how we can write a C program for this quadratic equation? Okay, along with checking these three conditions. Okay, if the determinant value is greater than 0, what we have to do? And if the determinant value is equal to 0, what procedure has to be, what code has to be written? And if the determinant value is equal to 0, what code has to be written? Okay, so if the determinant value is greater than 0, we need to calculate two roots, that is root 1 and root 2. If the determinant value is equal to 0, where we say both the roots 1 and 2 are equal, that is root 1 and root 2. Okay, and if the third case is if the determinant is less than 0, we calculate the real part and imaginary part, okay, separately for root 1 and root 2. Okay. So let's see what is the formula to calculate if the first case is satisfied, that is root determinant value is greater than 0. If determinant value is greater than 0, root 1 equal to minus b plus square root of b square minus 4ac by 2a. And if how we calculate the second root, that is root 2 equal to minus b square minus square root of b square minus 4ac by 2a. So this is how we calculate root 1 and root 2 if the determinant value is greater than 0. In case if the determinant value is equal to 0, both the roots are same. So root 1 equal to root 2, and only one formula we use here to calculate the root 1 and root 2. So what's the formula? Minus b by 2a. And what's the third case? If the determinant value is less than 0, we calculate the real part and imaginary part. So root 1 equal to minus b by 2a plus I into square root of minus okay, to the whole b square minus 4ac by 2a. Okay, this I represents the imaginary part, okay, the imaginary variable. And root 2, how we calculate root 2? Root 2 equal to minus b by 2a minus I into root of minus, okay, this is actually root of minus b square minus 4ac by 2a. Okay, so these are all the cases, three cases we have to check out for this quadratic equation. Okay, before checking these three conditions, we should calculate this determinant value. And how do we calculate this determinant value? What is the formula to calculate this determinant value? As you can see this line, determinant equal to b square minus 4ac. So after we calculate this value, b square minus 4ac, we check out these three conditions. What are all the three conditions? What has to be calculated? If determinant value is greater than 0, what if determinant value is equal to 0, as well as the third condition, determinant value is less than 0. And how do you calculate this determinant value? B square minus 4ac. Okay, b square minus 4ac. So 4ac. So the formula to calculate the determinant is b square minus 4ac. So after we calculate the determinant value, if it is less than 0, what has to be done? If it is equal to 0, as well as if it is greater than 0. Fine. Okay, so let me move on. So this is the first case. In case if my determinant value is greater than 0, I have to calculate root 1 and root 2. And what is the formula to calculate root 1? Minus b plus root of. Okay, so if you want to find out this root of function in C program, we have to use a built-in function called sqrt. Okay, so if you want to find out the square root for a given variable, where we use this built-in function square root of. So what's the spelling? sqrt of. Okay, so this is the built-in function which is used to calculate the square root of a given variable. Okay, so the root, how do you calculate the root 1? Root 1 equal to minus b plus root of b square minus 4ac. b square minus 4ac nothing but the discriminant value by 2a. And how we calculate the root 2? Root 2 equal to minus b minus of discriminant by 2a. So this is how we calculate root 1 and root 2 based on the discriminant value. Okay, so for discriminant value greater than 0, we have to find out both roots, that is root 1 and root 2. How do we calculate root 1? Minus b plus root of discriminant by 2a. How we calculate the root 2? Minus b minus root of discriminant by 2a. Okay, what is the second condition? If the discriminant value is greater than 0, meaning that both the roots are same. Root 1 and root 2 are same. How we calculate root 1? Root 1 equal to minus b plus square root of discriminant by 2 into a. And the same for, so this is actually for, this is for third condition. What's the second condition? If the discriminant value is equal to 0, we calculate, okay, we say that both the roots are same. So root 1 and root 2 are same. So root 1 equal to root 2, that is minus b by 2a. And what about the third condition? Finding out the complex value, complex root, we calculate both real part and imaginary part. Okay, what is the formula to calculate the real part? That is minus b by 2a. And what's the formula to calculate the imaginary part? That is root of minus discriminant by 2a. As you can see this slide, this is how we calculate the imaginary part for the third condition. Okay, when the discriminant value is less than 0. Okay, when the discriminant value is less than 0, we calculate the real part and the imaginary part. What's the formula to calculate the real part? Minus b by 2a. And what's the formula to calculate the imaginary part? That is root of minus discriminant by 2a. Okay, for the first root, we write x1 equal to real plus imaginary. For the second root, we write real minus imaginary value into I. Okay, how we calculate real part? Real part equal to minus b by 2a for the condition of discriminant less than 0. How we calculate imaginary part? Imaginary equal to root of minus discriminant by 2a. And what is the value for, what's the formula to calculate this discriminant? B square minus 4ac. Okay, and how we write the final answer for this complex root for the condition discriminant less than 0, that is root 1 equal to real plus imaginary into I. And how we write a second root? Second root equal to real part minus imaginary part into I. Okay, so this is how we find out the quadratic equation for 3 different conditions. Okay, let me show you the C program. So this is the C program to calculate if the discriminant value is equal to 0. Okay, if the discriminant value is equal to 0, both the roots are same, root 1 and root 2. And what's the formula to calculate if discriminant value is equal to 0? Minus b by 2a. Okay, so these are all the 3 conditions. As you can see here, this is a third condition. Okay, if the discriminant value is less than 0, we just find out the real part and imaginary part. We find out real part and imaginary part. And how we write the solution? How we write the final result? That is root 1 equal to real part. This is real part. This is imaginary part. We add a I variable along with the format specifier. What is this format specifier? For integer variable, we write %c. The format specifier for float is %f. Okay, so in order to display the decimal values, okay, according to certain points, we use this 0.2f. Okay, in case if you want to use %f alone, it's also allowed to use this %f to print out the real part and imaginary part. Okay, for the root 1 real part, imaginary part, we just add this I variable. That's it. And what about the next root? How we calculate the next root? If the discriminant value is less than 0, real part minus imaginary part into the I. So that's why root 2 equal to %2f minus %. This will give the real part and this one will give you the imaginary part along with the I value. Okay, that is I variable. Fine. Okay, let me show you the C program. Let me show you the C program to find out the quadratic equation. Let's see how we can write a C program for this quadratic equation. Okay, so as I have explained you how to find out this quadratic equation and what are all the condition has to be checked to find out the quadratic equation. If the discriminant value is greater than 0, where we have to find out the roots 1 and 2. If the discriminant value is equal to 0, meaning that both the roots are same, we find out only a single formula minus b by 2a for both the roots. Whereas if discriminant value is less than 0, we have to find out the real part and imaginary part. So how do we calculate the real part? So real part, that is minus b by 2a minus b by 2a. The imaginary part is plus I root of minus b square minus 4ac by 2a. But here it is for calculating the root 1 it is plus, for calculating the root 2 it is minus. That's only the difference. Okay, so these are all the conditions we have to check to find out the quadratic equation. What if discriminant value is greater than 0, equal to 0, and less than 0? Let me move on to the C program. So first we need to include the header files stdio.h and math.h. What is the use of this header file math.h? Where we have included this function sqrt of inside our C program. So sqrt is a built-in function which is available in this header file math.h. So that's why we have included this header file math.h. Fine. After that, the variables are declared. Okay, for finding out the discriminant value b square minus 4ac, we require the variables a, b, c. So that's why a, b, c variables are declared and followed by the variables root 1, root 2, the real part and the imaginary part, as well as the discriminant variable. Okay, so these are the variables are required to find out the formulas, different formulas and the different conditions. Okay, at first I'm just getting the value of a, b and c from the user. Okay, so after I get the value of a, b and c, before I check the conditions, I have to calculate the discriminant value. So how do you calculate the discriminant value? B square minus 4ac. Okay, so after I find out the discriminant value b square minus 4ac, I need to check those three conditions. So for calculating, okay, the condition, for checking the conditions, I have used the conditional statement if. So for the first condition, if the discriminant value is greater than 0, we need to calculate both the roots, root 1 and root 2. So how do you calculate root 1? Root 1 equal to minus b plus square root of discriminant by 2a. How do you calculate root 2? Minus b minus square root of discriminant by 2a. So after I calculate root 1 and root 2, root 1 and root 2 values are displayed here. And what's the second condition then? So the second condition is else if discriminant value is equal to 0. So if discriminant value is equal to 0, both the roots are same. So root 1 equal to root 2 minus b by 2 into a. Okay, so root 1 equal to root 2. Okay, after I calculate minus b by 2 into a, I just display the values of root 1 and root 2. Okay, what about the third case? So third case is given in else part. For the third case, that is discriminant value is less than 0, we calculate real part and imaginary part. For the root 1, we use real plus I into imaginary. For root 2, what is the formula? Root 2 equal to real minus I into imaginary. So after I calculate root 1 and root 2, I just display the values of root 1 and root 2 here. So this is how we write a C program to find out the quadratic equation. So to find out the quadratic equation, we have to check three cases. What if discriminant value is greater than 0? If discriminant value is equal to 0 and discriminant value is less than 0. Okay, so this is the C program for quadratic equation.